Alright, so for this video, instead of doing the note sheet, I'm going to work through some of the stoichiometry problems that you had on your homework. So, first thing going to do is I have to have a balanced reaction. So I can see that I don't have any coefficients here, so I'm going to go ahead and balance that. List my elements. So I've got potassium and I have chlorine. I have 1 and 2 on the reactant side, 1 and 1 on the product side. To balance this, I'm going to put a 2 here, update my totals. So I'm not balanced yet because I need 2 of the potassium. So in order to have 2, I'm going to put 1 there, and now I'm balanced. Remember that when there's no coefficient written, we mean that it's a 1. So I'm going to put a 1 there since this is a stoichiometry problem. I'm also going to go ahead and erase my work here just so I have room to work this problem. So I'm going to start with my known. I've got 106 grams of a potassium chloride, and the formula for potassium chloride is KCl. So that's my known. So I'm going to go ahead and I'm going to put a box around the KCl. My unknown is the mass of potassium. Potassium is K, and that's my unknown. So I'm going to put a box around my coefficient for potassium. Next thing I'm going to do is just do my table. I'm going to start with my known, 106 grams of potassium chloride, so KCl. And if I have grams of KCl on the top, I'm going to have grams of KCl on the bottom. So what I see a lot of people are doing is they're just putting grams of KCl, and then they're throwing things like a 2 or a 1 or whatever. Remember, when you see a G, that stands for grab your periodic table, you're going to need to calculate the molar mass, which means you're going to need to add up what is the weight of all these elements in the compound. So to get the molar mass of KCl, I'm going to need an atom of potassium, an atom of chlorine, and I got to put this on hold because I didn't grab my periodic table. So the mass of potassium is 39.10, and chlorine is 35.45. When you add that together, you're going to get 70.90 grams per 1 mole of potassium chloride. So my 70.90 is going to go here, and that's the weight of 1 mole of KCl. Now, ready for my next one. Remember, I'm always looking for that point that I can cross my bridge, my mole ratio bridge. So the 2 stands for 2 moles of potassium. This 2 over here stands for 2 moles of KCl. So I can actually go ahead and put 2 moles down here, and that's going to be of 2 moles of KCl. So I'm on this bridge right here. So I'm going to cross over, and I'm going to switch to what I'm going to need for my unknown. So this is going to be 2 moles of potassium. So I've made that switch. So now all my other calculations are going to have to do with the potassium that I need for my answer. And it's asking for the mass of potassium. So again, mass is going to be in the unit of grams, which means grab my periodic table, I'm going to need to look up potassium. Well, when you look up potassium, you don't even need to because you've actually used it in your molar mass calculation. It's 39.10 grams per 1 mole of potassium. And now I'm ready to put that in the calculator. So when I put that in the calculator, and I'm going to round for the right number of significant figures, I'm going to get 58.4 grams of potassium. And that's going to be my answer. So let's move on to the next one. I'm going to erase some stuff just so I have some room to write. Get rid of some of this stuff here so it's not quite so messy. And once again, I'm going to start my problem. So my known is 170.0 grams of copper. My unknown is going to be how many grams of zinc. Now looking at my chemical reaction, it's not balanced. So before I can get started, I need to balance this. So I'm going to list my elements: copper, zinc, and I notice that I've got this and I've got this. They're both on this. I've got NO3 on one side of the equation and I've got NO3 on the other side of the equation. So I'm going to use the trick to balancing, which is just to write this down as a group of atoms, which is what it is. Remember, the parentheses tells me that that's a group of atoms. If I have that same group on both sides, my count of atoms is going to be the same on both sides for that group. So let's do our tallies. We've got 1 copper, 1 zinc. Because of that little subscript there, I've got 2 NO3. On the other side, I've got 1 zinc, 1 copper, and there's no subscript here, so that means I only have 1 of these. So I'm balanced until I get down to the NO3. I have 2 on the reactant side, so I need to have 2 on the product side. I'm going to put 2 there. Now update my total for copper, update my total for nitrogen. Not balanced for copper anymore, so I'm going to need 2 here, and then update my total. So now it's balanced. Because this is a stoichiometry problem, I like to just put 1 in the blanks. And again, I'm going to erase my stuff so I have room to work. There we go. So now we're ready to begin the problem. So my known is going to be copper. So I'm going to put a box around that. My unknown is zinc. So I'm going to put a box around this one. I'm only going to box the 2 things that I need. So now I'm going to start my table. We're going to start with 172.0 grams of copper. If I have grams of copper on the bottom, we're going to need grams of copper on the bottom, which stands for grab your periodic table. Now the nice thing about this is I don't have to calculate anything, I just look it up. So you look on the periodic table and copper is 63.55 grams per 1 mole. On to the next. Now I'm always looking for that point when I've got the way I could go across this bridge. So I've got 2 moles of copper here, and that's going to go over to the bridge, which is 1 mole of zinc. So that looks like I can actually cancel these units off. So 2 moles of copper. Here I'm doing my first part of the bridge. Now I'm going to cross over to my product side, or my unknown side, and I've got 1 mole of zinc. Now I have to stop at grams of zinc. So once again, if I have mole on the top, I'm going to need mole on the bottom, and I'm going to grams, which means grab my periodic table. I grab my periodic table and I look up zinc. Well, 1 mole of zinc weighs 65.39 grams. My units are all canceling off. Goodbye grams of copper. Goodbye moles of copper. Goodbye moles of zinc. I'm left with grams of zinc, which is what I need in my answer. And because of space, I'm going to write my answer right there as soon as I calculate it. And the answer I'm going to need 4 significant figures. So it's going to be 88.49 grams of zinc. There you have it. Number 3. First thing I'm going to do is I'm going to annotate my problem and find my knowns and unknowns. So aluminum reacts with, there's my known, iron sulfate, known. How many grams of iron are formed? Well, grams of iron is going to be my unknown. So I look at my chemical reaction and, oh no, it's not balanced. So we're going to need to balance it again. This time I'm not going to use the trick, and I'm just going to balance this by separating out all the elements. So the other way I can do this is aluminum. I've got iron. I have sulfur, and I have oxygen. So I'm going to do my counts. I've got 1, 1, 1, and 4. On the other side, I've got 1 iron, 2 aluminum, I've got 3 sulfur atoms, and I've got 12 oxygen atoms. Because 3 times 4 is 12, 3 times 1 is 3. So I'm not balanced, obviously. I'm going to first go ahead and fix that aluminum. I'm going to put a 2 here, which means now I have 2. Iron I'm balanced on, so I'm going to jump down to the sulfur. 3 on the product side and only 1 on the reactant side. So I'm going to need a 3 here. Update my totals. 3, 3, and then 3 times 4 is going to be 12. Cross off my 4. Now, I'm good for aluminum, not good for iron. So I'm going to bounce back to the product side. In order to have 3 iron, I'm going to put a 3 right there. Update my total, and I'm balanced. So now that I've got my balanced equation, I'm going to go ahead and clean this up so I have room to work my problem. And because it's a stoichiometry problem, I'm going to go ahead and put a 1 here. Now, my known is grams of iron sulfate. Well, here's iron sulfate. Put a box around it. My unknown is how many grams of iron, so I'm going to put a box around that. So here's my bridge to go from one thing to the next. Start my table. 89 grams of iron sulfate, which is FeSO4. Oh no, it's grams, which means I'm going to need to grab my periodic table and calculate the weight of SO4. I'm going to do that right over here on the side. So I have 1 atom of, or the iron, I have 1 of those. For sulfur, I've got 1 of those. For oxygen, I have 4 of them. 1 iron, I look on my periodic table, and it weighs 55.84. Sulfur weighs 32.07. And everybody knows by now, oxygen is 16. So now, the total weight of the iron is going to be, well, there's only 1, so it's the weight of 1. The total weight of the sulfur is 32.07 because there's only 1 of them. For the oxygen, I got to multiply that. So it's going to be 4 times 16 equals 64. Now I'm going to add these together. So 64.00 plus 32.07 plus 55.84 equals 151.91 grams per 1 mole. Now I'm ready to work my problem. So, took all that time and energy to calculate the fact that it's 151.91 grams per 1 mole of FeSO4. Again, I'm always looking for that point when I can cross my bridge. Well, if I'm to moles, then I can cross the bridge. And I'm going to... All right, so I've got mole of FeSO4 on the top, so I'm going to need mole of FeSO4. I'm writing really big here. And I'm looking for when I can cross my mole bridge. Well, we have 3 moles there, so it looks like I can cross my bridge. So 3 moles of FeSO4. Now I'm going to switch colors because I'm going to cross over to my unknown side per 3 moles of iron, Fe. And I have to have grams of iron. So 1 mole of iron look on the periodic table, is going to be 55.84 grams of Fe. So now I've got what I need. My units are canceling off. Whoop. Goodbye grams, goodbye moles, goodbye mole, and I'm left with grams of Fe, which is what I need for my answer. And I'm going to switch colors and then write my answer down here so you can see it. So when I do my answer, I'm going to look to see I need two significant figures because of my known. So I'm going to round my answer to two significant figures, and that's going to be 33 grams of Fe. There you have it. So I'm going to do one of the ones on the back too. That was for bonus for the homework, but I'm going to go ahead and work that one too so you have one more example. I kind of like these ones on the back because there's more space to write. Mrs. Flint, you're not giving us enough space. Space, the final frontier. All right, here we go. How many grams of silver oxide are needed to react with 17.9 grams of hydrochloric acid to produce silver chloride in water? Well, first let me go ahead and figure out what I need to know here. My known is going to be here, and that is HCl, hydrochloric acid. And my unknown is going to be grams of silver oxide. There's my unknown, and that formula is Ag2O. Now I look at my chemical equation, and it needs to be balanced. So let me go ahead and balance this real quick. We've got Ag, we have oxygen, we've got hydrogen, we've got chlorine. I've got two of them. One of them, one of them, one of them. On the other side, I got one of them, one of them, one of them, and two of them. So, to balance this out, I'm going to need a 2 here, update my total, balanced for silver, balanced for oxygen, not balanced for hydrogen. So, I'm going to need a 2 here, update my total, update my other total, and dun-da-da, I'm balanced. So I'm going to erase my work so I have some room to write. All gone. And because I'm doing stoichiometry problems, I'm going to put a 1 here and a 1 here. Now, next thing I'm going to do is I'm going to box my coefficient for the known. So hydrochloric acid is my known, so I'm going to box that coefficient. And then I'm going to box the coefficients for my unknown, which is silver chloride. I'm going to completely ignore all the other coefficients. The only ones I need are the 2 that I have boxed. That's my bridge to go from one to the other. Start my table. 17.9 grams of HCl. Hopefully at this point you're going, oh my gosh, I'm going to need to grab my periodic table and calculate the weight of HCl, and you're right. We've got 1 hydrogen, 1.01. We've got chlorine, we have 1 of them, 35.45. There's only 1 of each, so I can just add them together, and that's going to give me 6.463, 36.46 grams per 1 mole. So that's going to go here, per 1 mole of HCl. Again, always looking for that point where I've got mole of something, and I've got it right here. So I'm going to go ahead and put in my mole ratio. 2 moles of HCl, so that's going right down here. And now I can cross my bridge and go from there to there. So to 1 mole of Ag2O. So my other mole ratio is going right there. Ready to continue my problem. So I have to end with grams. I've got mole of Ag2O on the top, so it's going to be 1 mole of Ag2O. And now I've got to calculate, because I'm going to grams, got to calculate how much Ag2O weighs. So we've got silver, and I've got 2 of those atoms. I've got oxygen, and I've got 1 of them. Silver weighs 107.87, looking on my periodic table. Oxygen is 16. The total weight of the silver is going to be 2 times 107.87, which is going to give me 215.74. Total weight of the oxygen is 16. Add these together, and my total mass is going to be 231.74 grams per 1 mole. So my 231.47 is going to go on the top, and now I'm ready to calculate. Alright, the answer in my calculator, rounded to 3 significant figures, is going to be 56.9 grams of Ag2O. And there you have it. We're going to stop right here. So hopefully you've got a little bit more information about how to do this, how to convert, and where those mole ratio conversions come in. Basically, what you're looking for is, as soon as you've got mole of your known on the top, then you can go ahead and use that mole ratio to convert to your unknown. That's all for now.